Alright, so keep in mind that for the inverse trig function, we cannot have two x values giving us the same y value. And so because of that, we need to restrict the domain. Notice for each of these problems, number 6, 7, and 8, you'll see that they all have that capital letter in each of them. And that's telling us that we do have an inverse trig function. So because, notice, these are inverse trig functions, and so because of that, we need to remember to restrict the domain. Okay, so restrict the domain. So when we look at these questions here, let's take a look at number 6 first. It says arcsine of negative half. Now for each of these problems, because we don't know what this is, we're going to say it's equal to x. And the idea here is that if we reinterpret that, this is the same thing as saying, let's solve sine of x equals negative half. If you kind of imagine from this original problem, because you see arcsine there, let's do the inverse, which is let's sine both sides. And so that's why we see that sine of x is equal to negative half, because those would end up canceling out. Now, because we're trying to solve this inverse trig function, we also need to keep in mind that we need to have our restriction, which is negative pi over 2 to pi over 2. So if we solve this, keep in mind if we look at our unit circle here, because we have to restrict it to this domain, that's one of those 3 takeaways I told you about on the previous page. That must mean that this pi over 2 to negative pi over 2 is all of the region in this area here, which means we should not have anything here. This is basically restricted area. We don't want to go into this area, because then we would end up with 2 x values giving us 1 y value for that sine. So we don't want anything here. So with that said, because we're now looking for when sine of x is equal to negative half, the idea now is within this area, we can now say, okay, well, sine of x is half, and that occurs at 2 spots, when you're at pi over 6, and also at 11 pi over 6, because that's in quadrant 1 and quadrant 4. However, because we're in this area here, notice how sine has to be negative. That must mean that we can't be in this area either, which means our only option is an answer in quadrant 4. When we look at our 2 answers, the only answer that satisfies quadrant 4 would actually be 11 pi over 6. The interesting thing about this problem is that if you want to get to 11 pi over 6, that must have meant that you crossed the restricted access area. We can't actually go in this area. It's basically like a no-fly zone. So if we cannot go in this area, our answer should actually not be 11 pi over 6. The only way we can get to 11 pi over 6, which is this location here, is if we backtrack. So if we go backwards, that's how we're going to get 11 pi over 6. And the answer that is similar to 11 pi over 6 would then be, because we're backtracking, negative pi over 6. So that's going to be our answer, negative pi over 6. Notice how negative pi over 6, it is still contained within our restricted domain, so this verifies that that is indeed our answer. Okay, let's do the same thing now for number 7. We see cosine inverse of x is equal to cosine inverse of negative root 3 over 2. So again, we're going to make this equal to x. And then if it's equal to x, keep in mind that this is the same thing as cosine of x is negative root 3 over 2. And this is going to occur when you are, keep in mind for the inverse cosine, when it has a restricted domain from 0 to pi. So we need everything to be within 0 to pi, which means if we draw a unit circle, if we only want things from 0 to pi, that means that we want quadrant 1 and quadrant 2. Everything else, again, like we did on the previous problem, is restricted access. Cross it out. So we do not want anything to go in this region here. Now, because our answer is a negative, this is telling you that because it's cosine, that must mean it's in quadrant 2, not in quadrant 1. So therefore, we know our answer is going to be in this area here, right there. Well, the only way that cosine can give you root 3 over 2 is if it has a reference angle of pi over 6, and to have pi over 6 in quadrant 2, that must mean that our angle is 5 pi over 6. And 5 pi over 6, it checks out. We're still contained within this restricted domain right here. So our only answer would be 5 pi over 6. Okay. Alright, on to the next one. Inverse tangent of root 3. Again, we can say let's make it equal to x. This means that what we're trying to solve for is when tangent of x is equal to root 3. Keep in mind, for inverse tangent, it needs the restricted domain from negative pi over 2. Keep in mind, it is non-inclusive to pi over 2, also non-inclusive. So as we look at our unit circle again, pi over 2 to negative pi over 2 is going to be contained within those two quadrants there. Let's draw the restricted area again. We do not want anything in quadrant 2 or quadrant 3. Now as we take a look back at our problem, because tangent is positive, and we're contained within these two quadrants, we're going to have our answer here. Okay. In quadrant 4, tangent will not be positive. So with that said, we know that tangent gives us a value of root 3 if we have a reference angle of pi over 3. Pi over 3 is still contained within these this restricted domain, so that's the answer that checks out. Okay. Alright, so let's go to a couple of these different problems now. What we have to do is go with a two-step approach here. Let's first solve the inside part and then solve the outside part. So if we know that the inverse cosine of negative 2/3, what we're going to get is like an angle measure. This is going to occur, keep in mind because it's inverse cosine, that's going to occur within quadrant 1 and quadrant 2 because this restricted domain was from 0 to pi, so we don't want anything here. In order to have a cosine that is negative, we definitely know that that's going to be in quadrant 2. If we're in quadrant 2, we see that basically the problem that we set up here is the same thing as saying negative 2/3 is equal to cosine of theta. Since we have this trig ratio of negative 2/3, we can actually set that up in our triangle here. And so we know that cosine is the same thing as adjacent over hypotenuse. So if that's the case, negative 2 is going to represent our base of the triangle, and then the 3 is going to represent our hypotenuse. By using the Pythagorean theorem, we'll be able to find that missing side there. So negative 2 squared plus b squared is equal to 3 squared. So b squared is equal to 9 minus 4, and so b is going to equal the square root of 5. So if we plug that right in there, now we have a complete triangle there, and what we're asked to find now is the sine of this given angle. And here's our given angle with those particular dimensions. So sine, we know, is opposite over hypotenuse. Opposite is root 5, and the hypotenuse is 3. So that is going to be our answer. Okay, going on to number 10. We can use the same approach here. So because we see that it's the inverse sine, keep in mind that this is the same thing as saying sine of theta is equal to root 3 over 2, but this also needs to be contained within our restricted domain. We know that for inverse sine, that's contained within negative pi over 2 to pi over 2. So the only area we can have would be quadrant 1 and quadrant 4. We should restrict our domain again, cross all that out like that. Now, so because we know that sine is positive, in quadrant 1 and quadrant 4, that's only going to occur in quadrant 1. Sine is opposite over hypotenuse, so if we fill out our triangle there, where opposite is root 3 and hypotenuse is 2, we can then find that missing side length here to then be able to get cotangent. Using Pythagorean theorem again, we see that root 3 squared plus b squared equals 2 squared. So we get that 4 minus 3 square root of that will give us a value of 1. So we know that this length is going to be a length of 1. With that, we can then find cotangent of our angle. We know that if tangent is opposite over adjacent, then cotangent must be adjacent over opposite. The adjacent side of our triangle here is a length of 1, and the opposite side is a length of root 3. Of course, we need to rationalize that, so cotangent of theta is equal to root 3 over 3, like that.